Welcome to my YouTube channel Mathematics for All. This is me Sachin Thakur. Today we are going to discuss about determinants and its properties. Let's move towards our topic. Determinants, the arrangements of n numbers in a square form between two vertical lines is known as determinants. Determinants may be it also contains rows and columns. Horizontal is known as horizontal rows, vertical column. Vertical column. Let's take example. Take an example of 2 by 2, that is 2, 3, 4, 5, and 3 by 3, that is 4, 5, 6, 7, 8, 9, 3, 2, 1. It is of order 3 by 3. It is of order 2 by 2. This is known as rows. This is known as column. Here, this is known as diagonal. Now let's move towards the how to find the determinants of 2 by 2 and how to find the determinants of 3 by 3 matrix. So first starts with 2 by 2 matrix. Determinant of 2 by 2, that is 2, 3, 4, 5. A equals to 2, 3, 4, 5 is given. Then we have to find determinants of A. It is given. Then we need to do simply. We simply write this 2, 3, 4, 5, and then we need to do 2 into 5. You have to multiply these two and then subtraction with these two multiplication, minus 4 into 3. Then what we get? 2 5 is 10 minus 12. What is the answer? Minus 2 is the answer. Now let's move towards 3 by 3 matrix. Determinant of 3 by 3. So determinants of 3 by 3 means 1, 2, 3, 4, 5, 6, 7, 8, 9. In such case, we have to first take 1 and these elements. By this covering this and covering this line, we need to write only this much. Whatever 5, 6, 8, 9. then minus 2, again cover this line, then we have 4, 6, 7, 9, and then plus 3, then we have to write, cover this line, we have 4, 5, 7, 8, and now this is a 2 by 2, then we can do it by same method, that is previous one. Now let's move towards the properties of determinant. Properties of determinants. First property, the value of the determinants remain unaltered by changing its rows into column or column into rows. Simple, it means if we change the rows into column or column into rows, then the value of the determinants will not be changed. The value of determinants remains unaltered by changing rows into column or column into rows. It will remain same, that is simply it is the transpose. Let's take an example. A11, A12, A13, A14. If this rows is changed into column and this rows is, and this column is changed into rows, that is A11, A12, A13, A14. The value of the determinant will be same. This was our B. So if we alter the rows into columns or column into rows, the value of the determinants will be same, it will not change. Now next property is if two rows or column of determinants are interchanged, then the determinant changes by just sign. Second property is if the two rows or columns are interchanged, then value of determinant changes by sign. Simply, what does it mean? Let's take an example, then it will be more clear. For example, A equals to 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 9, 8. Now if these rows and these rows are interchanged, then what happens? We have 5, 6, 7, 2, 3, 4, 8, 9, 8. Then just we have to change what? Here comes minus sign. This is the determinant value. New determinant value will be minus times A minus times a minus times value of determinant a. Simply this much will be the change. Now let's move towards our third properties. Our third property is, if two rows of the determinants are equal, then its determinant is equal to 0. If two rows or column of a determinant are same or are equal, then its determinant is equal to 0. It simply means if if two rows or column of the determinants are same. For example, here 2 3 4 2 3 4 5 6 7. If these rows and these rows are same, then its determinant value will be 0. Similarly, if 1 2 3 1 2 4 1 2 6, this column is same, so its determinant value will also be 0. Now next properties is, if each rows or column of a determinant is multiplied by a scalar, then the value of the determinant is also multiplied by a scalar. For example, let's first write it. If each element of rows or column is multiplied by a scalar k, then the value of determinant is also multiplied by k. It will be more clear if we take an example. For example, KA11, KA12, KA13, KA21, K times 22, K times 23, K31, K32, KA KA31, KA32, KA33. This is the determinant. Then it will be simply K times A11, A12, A13, A22, A21, A23, A31, A32, A33. Simply we have to take K outside, that is K times determinant. It is our fourth property. Now next moves towards our fifth properties, and it is, if rows or column or multiple of any row or column is added or subtracted from any other rows or column, then the value of determinants remain unchanged. This property is, if the rows or column or multiple of rows multiple of rows of any rows is added or subtracted from any other rows or column, then the value of determinants remains unaltered. It will be more clear if we take an example. So what is the example? Let's if a11, a12, a21, a22, a30, a13, a23, a31, a32, a33. If we subtract this minus this, that is R1 minus R2 is carried out, then nothing will happen. Simply A11 minus A21 and other A12, A1, 13, A13. Here A12 minus A22 minus A23 and other remains same A21, A22, A23, A31, A32, A33. Nothing will remain. Just change will be in row first, that is R1 minus R2 we have carried out. It remains same. Determinants value will remains same. There will be no change in the value of determinants. Now next property is if a determinant has a row or column of zeros, then its value is 0. Our next property is property number 6. If a determinant has a row or column of zeros element, then the value of determinant is 0. For example, if we have 0, 1, 2, 0, 3, 4, 0, 5, 4, then determinant will be 0. You can take it by expanding also. If we expand it, then we will get what value? 0 value. Our next property is property number 7. So it tells if a unit matrix, if A is a unit matrix, then its determinant is also unity. Unit matrix has its determinant unity. For example, a unity matrix has determinant unity. For example, 0, 0, 0, 1, 0, 0, 0, 1. Its determinant will be 1. Value of determinant is 1. Simply this much is the 7th property. Now 8th property. Our 8th property is if a triangular matrix, if a matrix is triangular, then its value is product of the diagonal element. Simply if the matrix is triangular, then the product of is diagonal, its product is diagonal matrix. Simply if a matrix is triangular, then its value is product of diagonal elements. Let's take an example. 1 0 0 2 3 0 4 5 6. So its determinant value will be 1 into 3 into 6. Simply multiply these diagonal elements. 1 1 3 3 6 6. So its determinant will be 18. Simply this much. It is a case of lower triangular matrix, and in case of over triangular matrix also there will be diagonal multiplication only. And our next property is, if each element of a line of determinant consists the sum of two terms, the determinant can be expressed as the sum of two determinants of same order. For this we have to write first our properties number 9. If each element of a line of determinant consists of the sum of two terms, then the determinant can be expressed in the as the sum of two determinants of same order. Let's take an example. 1 2 3 1 4 5 6 plus x 7 plus y 8 plus z. Then we can write simply two determinants of same order, that is 1 2 3 1 4 5 6 7 8. Here also 1 2 3 1 4 5 x y z. This will be the our last properties. Now this much for today. Don't forget to like, subscribe and press on the bell icon for more videos. Thank you for today.